Friends, we need to find the shaded area of this figure. That is the area of this right triangle we have here. Fascinating, let's do it. First, we have a very important piece of information here. So this here, that is the area of the semicircle. We know this because it says square units. So we can say that the area of a semicircle, which will symbolize this way, is not a zero but a circle, is equal to pi over 2. We won't include the units right now, we'll add them at the end. So we have that the area of the semicircle is pi over 2. We also know that the area of a semicircle is pi times the radius squared divided by 2. So this is going to be equal to pi over 2. Alright, so what are we looking for? To find the radius of the semicircle. Alright, so let's multiply by this 2 and divide by this pi. On the left side we have r squared. On the right side we get this here, pi halves multiplied by the 2 on top, multiplying, and the pi half. The pi in the denominator, here you can see everything simplifies. Look, and we end up with 1. We have r squared is equal to 1. By applying the square root to both sides of the equation, without applying the properties of the absolute values plus minus, because we only need the positive value, yeah, we can simplify the index with the exponent and get that 3 is equal to the square root of 1, which we all know is 1. Fascinating, we already have the radius of the semicircle, which is an important piece of information we needed. Look, the center of the semicircle is appearing here. So from here to here, it's 1. I must line this, and from here to here is also 1. So all of this is 2. Alright, we have the side of this square here. It's 2, over here it's 2, over here it's 2, and over here it's 2. And you see, we already have the base of our rectangle, whose area we need to find. We just need to find the height. This 2 here represents the entire side, not just up to here, but the whole side. Alright, now from here to here, no. How much does it measure? But we're going to call it x, alright? Notice here, the properties of lines when they are tangential to a circle or a semicircle. Here, we have this line, which is the side of the square, and it's tangential to this semicircle at this point, and also this line that is connected here to this other line is also tangent at this point. So since both are tangent and meet at a point, they must measure the same. If this measures 2, this over here will also measure 2, but from here to here, not up to there. So, only up to here is 2. But notice that the same thing happens here. We have a line that is tangent at this point, and another line that is tangent at this point and joins here. So if this is x, this over here will also be x. Phenomenal. So since all of this here measures 2, and this little piece is x that we are going to subtract, then the height of the right triangle will be 2 minus this part that measures x. Phenomenal. With this we can use the super powerful Pythagorean theorem to find the height of the right triangle, so let's do it. The Pythagorean theorem tells us that the hypotenuse squared is equal to the sum of the squares of the two legs. That is a squared plus b squared. What is the hypotenuse? It's all of this here. From here to here is 2, and from here to here is x. So the hypotenuse is 2 plus x, or x plus 2. Alright, then we have x plus 2 over here squared, which will be equal to a squared. It can be either of these two sides. Let's say it's this side, a 2 squared, plus the other side, which is from here. So we get to minus x squared. Excellent. We can then expand this binomials. Squared x squared here, plus the double product. The first, the second would be 2 times 2, which would be 4x. And plus the second one
would be 4.
And this equals to squared, which is plus the double, the first term squared, which would be 4 minus the double product, the first times the second 4x, and plus the second term squared, which would be x squared.
Great.
And look how wonderful everything cancels out here. X squared, 4 here, 4 here.
Let's
x on the left side,
the numbers indicated.
Right? Over here we have 4x, and this 4x here, when moved to the right side, becomes positive 4x, and here we have this 4 here. Very well. Very well. So what we have is 4x plus 4x equals x, which is equal to 4. Very well. So we can say that x is equal, let's put it here, x is equal to 4 over 8. Very well. Alright, simplifying, we get the fourth of 1 and the fourth of 8, which is 2. So ladies and gentlemen, x is 1/2, a magnificent number. With this, we have enough to find the shaded area. If you're enjoying the video, don't forget to subscribe and give it a like. Notice if x is 1/2 and here we had 2 halves. Minus x meaning 2 minus 1/2. Let's replace it. 2 minus 1/2. What else? I get it. 2 times 2 is 4. Minus 1 is 3. 3 halves. The result is 3 halves. Alright, so we already have the height and the base too, so we can now find the shaded area. We can say, ladies and gentlemen, that the shaded area is base times height divided by 2. So the base is 2 multiplied by the height, which is 3 over 2. And all of that divided by 2. Very good. Simplifying here and here, we see that the shaded area is equal to 3 over 2 square units. Fascinating. We already have the shaded area here. Let me know in the comments if you liked the video. And don't forget to subscribe and give it a like so you don't miss the next challenges. We'll see each other another time. Bye bye.